Hey, JP here. We're building some new parts for the submarine. I'm going to walk you through it. We're installing a new full daylight monitor. To do this, we need to print a rotating mount. The monitor is too big and it blocks your legs getting in and out. And it also blocks access to the oxygen tanks. To get around all that, the new monitor mount needs to be able to rotate up and out of the way. To do this, we need to pull out all the old mounts and all the instruments to make room. Then we'll knock together some rough prototypes to try. Then we'll 3D print and install the new mounts in the monitor to see if it all fits. This video is going to be a bit raw and unpolished. Not that any of my other videos are polished, but I'm going to try less editing and less reshoots. This may mean my shirt may magically change color during the video on different days, and I may drop stuff. A little more focus on the process we go through to make things. Let me know in the comments if this makes the video better, or no, clean up that video. There are standards. Okay, whatever you think, let me know. It's all good. Here's the problem. We had so much glare in the cabin the last time the sub was in the water that I couldn't even see the screen. We're tackling this in a few different ways. Pull down screens on the windows, some shade borders around the monitors, things like that. But the main solution is putting in a specialized full sun monitor. These are used in the movie industry to, well, be able to video outside. It's bigger and heavier than our existing monitors, so we need to figure out how to mount it and where to put all the instruments that it is displacing. When I start on a project, I always begin with sketches, piles and piles of bad sketches. I draw the good ones in CAD, then onto the 3D printer. Quickly make that jump from parts in your head to parts in your hand. The monitors are going to be mounted on a shaft going across the dash, and this way you'll be able to rotate it out, up out of the way, so it'll be easier to climb in and out of the sub. Here's the mock-up of the monitor mount, generation 4. And here's with our foam simulated monitor. The idea is that we can turn it out of the way when we're getting in and out, and then easily move it back into position without having to turn any screws or latches. And this is what it would look like with both monitors in place. And so we can rotate them out of position, getting in and out, and give us access to the tanks, and then be able to just rotate them down when we're using them. It looks like I'll have to put some kind of handle in there to make that a little bit easier, so I don't have to grab, the monitors. Make, test, repeat, make, test, repeat. The strength of using a 3D printer in your development process is you get to try things out. Now we're getting close to the final version. Now, instead of putting the rotators on a wooden dowel, they're going on a piece of aluminum C-channel. These are the brackets that get mounted on the edge of the cockpit of the submarine. And the one just drops into the other. We need to adjust the monitors or swing them out of the way. This just rotates. The rubber band keeps just enough tension to keep it from rolling when you don't want it to. From this video, it looks like I did all this by myself, but it just isn't so. I totally messed up and didn't get footage of the team at work. Sorry guys. I did manage to get one pic of Brad. That's all he gets for spending hours inside a hot submarine working on instrument placement. Now I've printed and mounted the final version of the brackets and also the rotator bar. So we can just drop that right in. And that'll allow the monitors to be rotated. And we're going to put rubber bands around here to get enough tension so it won't slip out during regular use. Okay, now I have the rubber bands on. You can see it provides enough tension so it doesn't freely rotate. Now we'll take this off and then put the monitor brackets on there and see how well that holds up. The small monitor gets mounted on this little shelf, and that gets mounted on the crossbar. The larger monitor gets these little side holders that are then also slid over the crossbar. Okay, now that we've got all the parts built and just roughly tested, it's time to put this whole monitor bar together. First step is to take off the rotators. These are all just friction fit. First, we're going to put on the small monitor shelf. And once we get it all laid out in the sub, we'll adjust them back and forth to get them just how we want. And now this is the first of the large monitor shelves. Yep, blue one goes on first. And then we put the rotators back on. Okay, and there you have it. Next, we'll just do a test fit with the monitors. First, we're going to install the new ultra bright monitor that'll let us see when we get a lot of glare coming into the sub. It's also just a friction fit, so it kind of fits in there pretty tight. And we slide this guy over. And there we have it. If we need to, you can see there's a pair of holes here and here that we can put a tensioner on it to keep this tight. But right now, it's on there. Now the small monitor, which is going to be the sensor display, for now, we're just going to put a piece of double-sided foam tape on the deck. And that actually should hold it on pretty good. I think we need to move everything down toward me just a little bit, so the monitor is out of the way of the rotator. And there we have it. Now let's go and see how it fits inside the sub. A great big thank you to our Patreon members out there. You know, the full daylight monitor, and come to think of it, the plastic for the 3D printers was paid for by your contributions, and we really appreciate it. To find out more about our Patreon program, there's a link in the description below. In this project, there were lots of little details. Some of them were pretty simple, like swapping out these big thick VGA cables for these extra flexible HDMI cables. Some of the details were projects in their own right. The new computer and monitor are 12 volt, so we can tie them directly into main power. They don't need to go through the inverter, and that's great. But it does mean we have to build power harnesses for them. And finally, we needed to remove all the analog sensors and the independent digital sensors, it's about 10 of them, and figure out new places for them to go, where we can still see them in spite of taking up all that dash space with the new monitor. Here's what it looks like all installed. I put a cargo blanket over the front window so you can tell what's going on inside as opposed to what's just happening outside. And you can see the new instrument placement. And this allows the screen to be folded up in a way so you can both get at the connections and also so your knees don't hit as you're climbing in and out. So then once you're on board, you flip that down and you're ready to go. Project done. The monitors are in. Now we need to really install the computers and hook everything back up. And then we're in for a lot of testing. In addition to the system and instrument changes, we made modifications to the life support system. However, without the system being online, we have not been able to test that completely. So, more testing. Some of the changes we've made impact the checklist and operational procedures. That means that in addition to testing, we have some crew training to do. But that's the nature of submarines and spaceships. With all that, my best guess is that we're about 3 weeks away from putting Belle back in the water. I'll post an update when we get close. Be sure to subscribe to the channel so you can check out the latest. Thank you for watching. JP Aerospace, America's other space program.